Okay, so welcome to today's kind of study session kind of video, I guess. Today we're doing a bunch of implicit differentiation. For all these questions, we're taking the derivative with respect to x, all right? And since this is kind of like a study session kind of feel I want to do, I encourage you guys to try these questions out kind of on your own. So just pause the video, try the question, and then you can, I guess, resume it, and we'll work through the question together if you're kind of lost, okay? So let's look at question A here. We've got the derivative of this kind of equation here. We've got x's and y's. Now, technically, you could isolate for y, but in this case, we're doing implicit differentiation. So let's just start taking the derivative with respect to x, okay? So on the left side here, let's push that 2 to the side for a second. Okay, the derivative of x squared, that's going to be 2x. And since we're taking the derivative with respect to x, we don't have to do like a dx over dx thing. Okay, the variable matches in this case. Now, here, let's take the derivative of this guy. We can push this 3 to the side for a second. The derivative of y cubed, well, that's just going to be 3y squared. Okay, but because of chain rule, we have to take the derivative of y as well, because y is a function of x, but we don't know what that is written explicitly. So in this case, just for now, we're going to write dy over dx. That's just the derivative of y with respect to x. And on the right side here, we've got this funky looking thing here. Looks kind of scary, but notice there's no variables, so this is actually just a constant. This is just going to be 0. Okay, the derivative of this constant is 0. So now we can simplify a little bit. We've got 4x. This is 9y squared dy over dx equals 0. And all that's left to do now is to solve for dy over dx. So we're going to subtract 4x from both sides. You're going to get 9y squared dy over dx is equal to minus 4x. And now we're just going to divide both sides by 9y squared. You're going to get dy over dx is equal to minus 4x over 9y squared. And that's question A. Now, let's look at question B over here. Okay, so in this question here, this is a little different from question 1, right? Because notice here we've got a product rule here, right? We've got x, and then this y here is a function of x. So this is a product rule. We have two functions being multiplied together. So the left side is going to come out kind of similarly here. We've got 6, the derivative of x cubed, that's going to be 3x squared. And then we've got 3, the derivative of y is just going to be dy over dx. And here, because you have a product rule, we have to take the derivative of this first function, which is just going to be 6, right? The derivative of 6x is 6. We multiply it by the second function, and then we're going to add that to the derivative of the second function, which is minus 2y to the minus 3 with a implicit differentiation here. This is dy over dx, right? And then we're going to multiply that by that first function, that's 6x, okay? So simplify this a little bit. You're going to get 18x squared minus 3 dy over dx is equal to 6y to the minus 2 minus 12y to the minus 3, I forgot x here, dy over dx. All right, and so now we can just bring these two terms without the dy over dx to the right, and these with the dy over dx, I'm going to group them on the left, okay? So I'm going to have 12xy to the minus 3 dy over dx minus 3 dy over dx. Those are my green terms. And then here on the right side, I'm going to have 6y to the minus 2 minus 18x squared. Now I'm going to factor out a dy over dx. So dy over dx times 12xy to the minus 3 is equal to 6y to the minus 2 minus 18x squared. And now I'm going to divide both sides by the bit in the brackets. So I'm going to get 6y to the minus 2 minus 18x squared, and that's all going to be divided by 12xy to the minus 3 minus 3. Okay? And if you want to simplify this a little bit, you can factor out a 3 on the top and factor out a 3 on the bottom. That's just going to cancel out. You're going to end up with 2y to the minus 2, minus 6x squared, all divided by 4xy to the minus 3 minus 1. Okay? On to question C then. All right, so this question is kind of similar to question B. We've got a product rule over here, and we've got another product rule over here. Notice we've also got like some chain rules going on over here and over here. Okay, so lots of stuff happening. Let's just take it one step at a time. So this first term here, we're going to have to do a product rule like I just said. So the derivative of this first function, that 3y, is going to be 3 dy over dx. And then we multiply it by the second function, this e to the 2x. Then we add it to the derivative of e to the 2x, which is just e to the 2x times 2 because of chain rule. And then we multiply it by 3y, that first function. Then we subtract it by the derivative of 4 to the y. And that's just going to be an exponential derivative, right? This is going to be 4 to the y ln of 4. And now, because of chain rule, we have to take the derivative of y. So that's just going to be dy over dx. And that's going to be equal to, and here we have another product rule. So the derivative of that first function is just 1. So 1 times sine 3y is just sine 3y. And then we add it to the derivative of sine 3y. That's cos 3y times, and now the derivative of 3y, that's 3 dy over dx. And then we multiply by that first function here, that's just x, okay? Now let's take a look. We've got this term here with the dy over dx, same over here, and same over here. So those are the terms I'm going to push to the left. Here we've got two terms without dy over dx. Those are the ones that I'm going to keep to the right, okay? So let's just write this out real quick. We've got 3 e to the 2x minus 4y ln 4, okay? And then here we've also got this minus 3x cos 3y. And now I've gathered these three terms on the left. I'm going to factor out a dy over dx, okay? So you can do that all in one step if you really want to. And then on the right here, we've got sine 3y minus, and then here I'll simplify this a little bit. That's just going to be 6y e to the 2x. Okay. And last but not least here, just to find or simplify this, to solve for this, we're just going to divide both sides by the bit in the brackets. Okay. So dy over dx is going to be equal to sine 3y minus 6y e to the 2x, all divided by 3 e to the 2x minus 4 to the y ln 4 minus 3x cos 3y. And that's question C. On to question D then. All right, so this question has quite a lot going on here. We've got a product rule over here. We've got a chain rule in here. And then this looks kind of like a quotient rule. But to be honest, I'm not a very big fan of quotient rule. I like to just rewrite this as 4xy to the minus 1. And then here we just have a product rule instead. But at the end of the day, it's up to you. If you want to use quotient rule here, that's absolutely fine. You're getting the same answer anyway. Okay? So let's just jump right into it then, instead of just staring at this kind of intimidating question. So one step at a time, right? This first term here, we're going to do a product rule. So the derivative of cos x squared plus y, that's going to be minus sine of x squared plus y. And then chain rule tells me I have to take the derivative of this inside. So it's going to be 2x plus dy over dx. and then we multiply it by that second function here, this 3 to the y. Okay, and now we have to add that to the derivative of that 3 to the y, so that's going to be 3 to the y ln of 3, and then the derivative of y, that's dy over dx, right? And then we multiply by that first function, this cos of x squared plus y. And then we add that to the derivative here of 5x cubed, that's going to be 15x squared. And that's going to be equal to this derivative here. This is another product rule. So the derivative of 4x, that's going to be 4. We multiply it by the second function, y to the minus 1. We add that to the derivative of y to the minus 1, which is minus y to the minus 2 dy over dx. And we multiply it to that first function, this 4x term over here. Okay. Now, this is quite an awful looking expression. And it's going to get a little worse because we have to distribute this. So yeah, and then distribute this as well. So that's going to be kind of annoying, but let's just do that anyway, okay? Yeah, and make sure we're very careful so we don't mess anything up, right? So we've got minus 3 to the y times 2x sine of x squared plus y minus 3 to the y sine of x squared plus y dy over dx plus 3 to the y ln 3 cos of x squared plus y dy over dx plus 15x squared is equal to 4y to the minus 1 minus 4x y to the minus 2 dy over dx. Okay, that's kind of awful looking, but whatever. Here we've got terms with dy over dx, same over here and over here as well. And this doesn't have dy over dx, neither does this guy, and neither does this guy. Okay, so those green guys we're going to keep on the left. We're going to push them all to the left and then factor out dy over dx. Those pink terms, we're going to push them all to the right. Okay, so we're going to have, let's see, minus 3 to the y sine of x squared plus y plus 3 to the y ln 3 cos of x squared plus y, and now we're going to have plus 4xy to the minus 2, right? And now that they're all on the left, we can factor out the dy over dx. And on the right here, we've got 4y to the minus 1 plus 3 to the y 2x sine of x squared plus y minus 15x squared. And all that's left to do now is to divide this equation, both sides, by the bit in the brackets here. So dy over dx is equal to 4y to the minus 1 plus 3 to the y 2x sine of x squared plus y minus 15x squared, all divided by minus 3 to the y sine of x squared plus y plus 3 to the y ln 3 cos of x squared plus y plus 4xy to the minus 2. Okay? And that's all you have to do for question D. Oh wait, let me fix this real quick right here. This is plus. Okay. Now question E over here. Okay, this one's a fun question. I actually really like this one. As you can see here, we've got this like ln term, right? And obviously this looks kind of annoying to do because you're going to have to do a chain rule, and then inside that chain rule, you're going to have to do a product rule, and then you have to do implicit because this is a function of y, right? But honestly, if you guys, think back to your log properties, right? This is actually not too bad of a question because you remember, okay, well, you should remember, right, that log of AB, right, if you have two things being multiplied inside your log, you can rewrite that as log of A plus log of B, right? So you can really actually just separate this this ln here. And also, if you remember, log of A to the power of B, you can pull that to be to the front. This is just B log A, right? So this ln term here, you can rewrite this, right? This is just ln of 2 plus ln of x cubed plus ln of y. And now you can use the second log property that I wrote here. You can rewrite that as ln 2 plus 3 ln x plus ln y. Okay? So instead of taking the derivative of this, I'm going to take the derivative of this guy, okay? Which seems a lot nicer because the derivative of ln 2, that's a constant, that's just 0, plus the derivative of this, let's push the 3 to the side for a second, the derivative of ln x, that's just 1 over x. And the derivative of ln y is just 1 over y dy over dx. And that's a lot easier to do than that derivative, right? Okay. Now the derivative of x, that's just 1, minus the derivative of tan y, that's secant squared y dy over dx. Okay. Now, here we've got terms with dy over dx's. Okay. And this guy doesn't have dy over dx. So let's push those green terms to the left and factor out my dy over dx. We've got 1 over y plus secant squared y. Now we're going to factor out the dy over dx. And here we've got 1 minus 3 over x. Okay. And now we just have to divide both sides by this thing in the brackets. So dy over dx is equal to, I'll write this as x to the minus 1 because I don't like having fractions on top of fractions. That just looks awful, to be honest. And same over here with this 1 over y. I'll write that as y to the minus 1, okay? Plus secant squared y. And that's all you got to do for question E. Okay, on to question F then. All right, so the derivative of sine x plus y to the 3, that's going to be cos of x plus y to the 3. Now, because of chain rule here, I have to take the derivative of that inside composite function here, right? Well, this is a composite function. I'm taking the derivative of the inside one. So that's going to be 1 plus 3y squared. And then we have to have that dy over dx. And that's going to be equal to the derivative of the inverse cotangent of x squared. So minus 1 over 1 plus, and instead of x squared, I'm going to have x squared squared, right? The inside function stays as it is. And now we multiply by the derivative of the inside function. That's going to be 2x. All right. Now let's distribute this a little bit here. So we've got cos of x plus y to the 3 plus 3y squared cos of x plus y to the 3. That's a weird looking bracket because the first one was so small. dy over dx. And then here, I'll put this on top. We've got minus 2x over 1 plus. Instead of x squared squared, I'll write that as x to the 4. Now we're going to subtract both sides by this cos x plus y to the 3. So 3y squared cos of x plus y to the 3 dy over dx is equal to minus 2x over 1 plus x to the 4 minus cos of x plus y to the 3. And all that's left to do now is to divide both sides by this bit over here. Okay, so dy over dx is equal to minus 2x over 1 plus x to the 4 minus cos of x plus y to the 3. And that's all going to be divided by 3y squared cos of x plus y to the 3. Okay? And that's the answer for F. All right, so on to G then. So this one, you gotta be a little careful here. We've got a product rule here, right? So the derivative of this first function here, that's just gonna be dy over dx. And we're gonna multiply it to secant x. And we're going to add it to the derivative of secant x, which is sec x tan x. And then we're going to multiply it to that first function, that y, right? And then we're going to subtract the derivative of y squared. That's going to be 2y dy over dx. And that's going to be equal to the derivative of this exponential function. That's going to be 6 to the x ln 6. Okay, now here we've got a term with dy over dx. Same over here. This guy doesn't have dy over dx. Neither does this guy. So the green guys are going to stay on the left here, and then we're going to factor out the dy over dx. So we've got secant x minus 2y. We pull out that dy over dx. And on the right, we've got 6 to the x ln 6 minus secant x tan x. Maybe I'll put the y in the front here. Okay. And now we just divide both sides by this sec x minus 2y. So dy over dx is equal to 6 to the x ln 6 minus y sec x tan x, all divided by sec x minus 2y. And that's your answer for G. All right, so H over here, we've got a product rule right over here, right? And we've got a chain rule here, we've got a chain rule here, and then we've got a chain rule this guy as well, right? Because of implicit. Okay, so let's just take this one step at a time then. Now here, notice, right, I mentioned before, this is a chain rule, but technically, right, remember what I said before, if you have the log of a to the b, you can just pull that exponent out to the front. It's just going to be b log a. So instead of doing a chain rule, I could rewrite this term, this 8 ln x cubed, as 24 ln x, right? So instead of taking the derivative of this, I'll take the derivative of this guy, which is just 24 times 1 over x, right? So a lot nicer. And now the derivative of this guy, okay, so the derivative of that first function is just going to be 1. So 1 times tan of 4 plus y squared. And then we add that to the derivative of my second function here. The derivative of tan is secant squared. Okay, I'll leave this inside function as it is. And now I'll take the derivative of the inside function. The derivative of 4 is 0, because it's a constant. The derivative of y squared is 2y, and now chain rule again, right? The derivative of y is dy over dx. And then we multiply it by that first function, this x over here, okay? Now, we've got this term here with the dy over dx, and this guy doesn't have dy over dx, neither does this guy. And I guess since there's only one term here with dy over dx, I can just keep it on the right instead of moving it to the left. I'll move this guy, this pink guy, to the left, okay? So we've got 24 over x minus tan of 4 plus y squared, and that's going to be equal to 2xy secant squared 4 plus y squared dy over dx, right? And now I'm just going to divide both sides by this bit over here. So once again, I don't really like having fractions on top of fractions, so I'll write this as 24x to the minus 1. Yeah, and then here I have tan 4 plus y squared, and that's all divided by 2xy secant squared 4 plus y squared, and that's going to be equal to dy over dx. All right. Okay, let's move on here to the next one, I. All right, so here we've got a product rule. Here we've got another product rule, and then this, we can rewrite this as y to the 3 over 2, okay? This is a 3, by the way. All right, so the derivative of this first term here is a product rule, so the derivative of x to the 4 is 4x3. We multiply it by the second function, then we add it to the derivative of that second function, this y, so that's going to be dy over dx, and then we multiply it by the first function, that x to the 4. Then we add that to the derivative, again, of just 5x first, so that's just going to be 5 times secant y. Then we add that to the derivative of my second function, so that's going to be sec y tan y. And then the derivative of y, because of chain rule here, right? It's just going to be dy over dx, and then we multiply by that first function, so it's going to be 5x. Okay? And then on the right side of my equation here is just going to be a power rule. That's going to be 3 over 2, y to the 1 over 2. Okay, instead of 1 over 2, maybe let's just do a square root here, and then dy over dx. Okay, so here we've got a term with dy over dx, same over here, and same over here. And here we've got no dy over dx's. Okay, but since these two pink terms are already on the left, how about we just put the dy over dx's on the right, and then we're going to factor out the dy over dx. So on the left, we've got 4x cubed y plus 5 secant y, and that's going to be equal to, and then on the right, we've got 3 over 2 root y minus x to the 4 and minus 5x sec y tan y, and then we factor out a dy over dx from all three terms here. And all that's left to do now is to divide this entire equation by the thing in the brackets over here, right? So we've got 4x cubed y plus 5 secant y, and that's going to be equal, divided by, 3 over 2 square root y minus x to the 4 minus 5x sec y tan y, and that's going to be equal to dy over dx. All right. Next over here we've got j. So once again, I'm not the biggest fan of quotient rule. In this case, I could see that with something like this. I could rewrite this as simply 2x to the 4 minus 3 to the minus 2. And instead of quotient rule now, this just becomes a simple power rule. So why not do that, right? On the left-hand side here, we've got a chain rule, right? We've got this kind of function in the exponent, and we've got a product rule in there. So let's take this one step at a time again. So the derivative of e to the xy squared is just going to be e to the xy squared times, now the derivative of x times y squared is a product rule, so the derivative of x is is 1, and 1 times y squared is y squared. And then we're going to add that to the derivative of y squared, so that's going to be 2y, and then we have a dy over dx. And then we multiply it by the first function, that x over here, okay? And that's going to be equal to the derivative of this over here. That's going to be minus 2 2x to the 4 minus 3 to the minus 3. And then we have to take the derivative of the inside. That's just going to come out to 8x cubed, yeah? Okay, so let's distribute this a little bit here. We've got y squared e to the xy squared, right? Like this, and then like this. And then we're going to add that to 2xy e to the xy squared dy over dx. And that's going to be equal to, and we're going to take this and multiply this to this 8 over here. So we've got minus 16x cubed times 2x to the 4 minus 3 all to the minus 3. Now, let's subtract both sides by this over here. So we've got 2xy e to the xy squared dy over dx, and that's going to be equal to minus 16x cubed times 2x to the 4 minus 3 all to the minus 3 minus y squared e to the x y squared. And all that's left to do now is to divide both sides by this bit over here. Okay, so dy over dx is equal to minus 16x cubed times 2x to the 4 minus 3 all to the minus 3 minus y squared e to the x y squared, all divided by 2xy e to the x y squared. All right. Oops. And let's scroll down a little bit here. Let's look at question K. Okay. So this one, this right-hand side here, we'll read this as y to the 2 over 3. And on this right-hand side here, once again, notice we have a log. So we can kind of split this up here. This is the same thing as ln of x cubed plus ln of y to the minus 4. And then once again, we can just bring those exponents out to the front, right? This is just 3 ln of x minus 4 ln y. And I think we'd much rather take the derivative of this than this kind of chain rule, product rule kind of thing here, right? So yeah, let's do this. So this is just 3 times 1 over x, that's just 3 over x, minus 4 over y times the derivative of y is dy over dx. Okay, and that's going to be equal to, the derivative of this guy is just 2 over 3 y to the minus 1 over 3 times dy over dx. Okay, so let's just take these two terms and group them together, right? These dy over dx terms. And since there's only one term without dy over dx, I think I'll just leave this guy on the left. So you've got 3 over x, and that's going to be equal to 2 over 3 y to the minus 1 over 3. We'll bring this guy over, plus 4 over y, and then we'll factor out the dy over dx. And all that's left to do now is to divide both sides by this thing over here. Okay, so we've got 3 over x. Okay, maybe I'll write that as 3x to the minus 1. And that's going to be divided by 2 over 3 y to the minus 1 over 3 plus 4y to the minus 1. And that's equal to dy over dx. Okay. Let's get question L then. All right. So here we've got a kind of chain rule here, and then inside that chain rule we've got a product rule, right? So let's do this left side first. That's going to be just 12x squared, simple, nice, okay? And on the right side, it's going to be a little less simple. So first things first, take the derivative of the outside function. That's going to be 2 times 2x to the 4y minus sine y to the 1, okay? But I'm not going to write to the 1 because that's kind of useless. And then we multiply by the derivative of the inside function. So the derivative of 2x to the 4 first, right? Because you have a product rule. That's going to be 8x to the 3. We multiply that by the second function here. That's y. Then we add that to the derivative of that second function. That's going to be dy over dx. And then the derivative, oh, not derivative, we just multiply it to the first function. That's going to be 2x to the 4. And then we subtract that by the derivative of this function here. That's going to be cos y. And then we have a dy over dx. All right. So, yeah, in this case, I don't really feel like expanding, like multiplying this to this guy and that guy, okay? But notice I don't have any dy over dx's on this left side. So actually what I'm going to do is I'm going to divide both sides by this guy, okay? So I'm going to have 12x squared all divided by 2 times 2x to the 4y minus sine y. And that's going to be equal to And then since I have this term here, this kind of thing in the brackets, and both of these terms have a dy over dx, I might as well just kind of group them right away. So this dy over dx times 2x to the 4 minus cos y. Okay. And now I'm going to subtract both sides by this term, that 8x cubed y. So we've got this. I can simplify that a little bit here. This is just going to be 6x squared over 2x to the 4y minus sine y. And I'm going to subtract this 8x cubed y. And that's going to be equal to dy over dx times 2x to the 4 minus cos y. And all that's left to do now is to divide both sides by the stuff in the brackets here. Okay, so you're going to get 6x squared over 2x to the 4y minus sine y minus 8x cubed y, all divided by, and let me scroll down a little bit here for you guys. That's all divided by 2x to the 4 minus cos y. Okay, and maybe I'll extend this line a little bit here. All right, and that's going to be equal to dy over dx. Okay. Now, actually, yeah, we can simplify this a little bit more too. We can factor out a 2x squared on top, so we've got 2x squared, and here we've got 3 divided by 2x 4y minus sine y minus 4xy, all divided by 2x 4 minus cos y. Okay? Yeah, leave it like that. All right. Next up here, question M. All right, so let's look at this guy first, okay? Once again, we have a log, okay? I want you guys to get really, really good at recognizing when you have logs here, right? This is just ln of x cubed y to the minus 1, right? And we can simplify that as, well, ln of x cubed plus ln y to the minus 1, I mean, right? And that's just going to be 3 ln of x minus ln of y. And I think we'd all rather do this derivative than the derivative of this guy here where we have a quotient rule, right? Okay, so on the left-hand side here, this is the same thing as a 4 like this, 4 plus 6y to the 1/2. Okay, so this is going to be a power rule on the left side here, right? So we're going to have 1/2 of 4 plus 6y to the minus 1/2. And then we're going to take the derivative of that inside function. So the derivative of 4 is 0. The derivative of 6y is 6 times dy over dx. Okay? And then on the right side here, the derivative of 3 ln x, that's 3 times 1 over x, or 3 over x. Okay? Minus the derivative of ln y is just 1 over y times dy over dx. Okay. Now we've got a term here with dy over dx, same over here, and this guy does not have dy over dx. So I'll keep him on the right. I'll take these two dudes and put them on the left, and then factor out the dy over dx. All right. So we've got, well, we have a 1/2 here, and we have a 6 over here. So I'll write that as a 3. 4 plus 6y to the minus 1/2 plus 1 over y, or I'll write that as y to the minus 1. And then we factor out a dy over dx. And that's equal to 3 x to the minus 1. And now we just divide both sides by the stuff in the brackets here. So dy over dx is equal to 3 x to the minus 1, all divided by 3 times 4 plus 6y, all to the minus 1/2, plus y to the minus 1. Okay. Now over here we've got n, and there's really nothing too bad about this question except for this like kind of chain rule thing in the exponent, okay? But let's just jump into it and see what happens, right? So the derivative here of this first term, that's going to be 12y to the 3. And then we have a dy over dx minus, and then this is an exponential derivative, so that's going to be 2 to the y to the 4. And then we have to take the derivative of, well, let's not forget that ln 2 first, okay? The derivative of that y to the 4. So it's going to come out to 4y to the 3. And then we multiply by dy over dx. And that's going to be equal to the derivative of cos inverse, or inverse cos of x. That's minus 1 divided by the square root of 1 minus x squared, right? Now, let's see here. On these two terms, we've got dy over dx, so we can factor that out. But there's also, if you notice, a factor of, well, great GCF, okay, of 4y cubed. So let's pull that out as well, right? We've got dy over dx, and then here we've got 4y cubed, right? Just to simplify this a little bit here. And we've got 3 minus 2y to the 4 ln 2. And that's going to be equal to minus, I'll write this as 1 minus x squared to the minus 1/2, okay? So just so we can get rid of the fractions. And now we're just going to divide both sides by this term here, okay? I forgot to underline this before on top, but you can notice these two terms of the dy over dx are already on the left, so I didn't have to do any like rearranging. Forgot to mention that before, but I think you could have seen it by now. All right, so we divide both sides by dy over dx. We get, not by dy over dx, by the thing being multiplied to dy over dx, this thing in the brackets here. So now we have dy over dx is equal to minus 1 minus x squared to the minus 1/2. And that's going to be divided by 4y cubed, 3 minus 2y to the 4 ln of 2. And that's going to be your answer for n. Now, last but not least here, we've got question O. So once again here, notice we've got a log, right? And whenever you have logs, start thinking like, okay, can I split this up? Can I pull out the exponent to the front? And in this case, you can, right? This is just going to be 2 log base 3 of y, okay? And maybe this guy, I'll simplify this a little bit. I'll rewrite this as plus x to the 4 y to the minus 3 because I'm not the biggest fan of quotient rules, okay? And the right side, we'll just leave it as it is, okay? Inverse tan of y. All right, so the derivative of this first term here, that's going to be 2 times 1 over y ln 3, right? And then we have to do dy over dx. And we add that to, and here we have a product rule, right? So let's do this one at a time. The derivative of my first term here, that's going to be 4x cubed. We multiply it to that second function, y to the minus 3. Then we add that to the derivative of my second function, which is minus 3y to the minus 4, so minus 3y to the minus 4. Then we have to do a dy over dx, and then we multiply it to that first function, that x to the 4. Okay, and this is going to be equal to the derivative of this guy. So we push that 3 to the side for a second. The derivative of inverse tan of y is 1 over 1 plus y squared. And then we have to do dy over dx. That's the derivative of y. Now, here we've got a term with dy over dx. Same over here and same over here. It's just this guy that doesn't have dy over dx. So I'll leave him on the left. Everything else I can push over to the right. Okay. So here we've got 4x cubed y to the minus 3. And that's going to be equal to 3 over 1 plus y squared. And then I'll push these guys over and factor out the dy over dx. So I'm not going to write this dy over dx yet. Here we have minus 2 over y ln 3 plus 3 y to the minus 4. x to the 4. And now I'm going to factor out from these three terms the dy over dx. And now all that's left to do is to divide both sides by the stuff in the brackets here. So 4x cubed y to the minus 3, all divided by 3 over 1 plus y squared minus 2 over y ln 3 plus 3y to the minus 4 x to the 4 is equal to dy over dx. All right, so that's going to wrap it up for today's kind of study session. I hope it helped you in some way. If you have any questions, if you see that I made any mistakes, just let me know in the comments. And if there's another topic that you want to do kind of a study session for, yeah, just let me know in the comments below. All right, have a great day, guys. Bye.